Moving on to question 7 now, we have a question here on 3x3 matrices, and then this is in terms of vectors as well. So a bit of a mixed question here, and it's a decent question. There's a couple of little tricky parts to it, but overall, quite a nice question. Okay, so let's jump straight into it. So part A, we have to find the values of k for which the matrix M has an inverse. So we've got this matrix M, and we're told that k is a constant, okay? So if M has an inverse, what that means is that the determinant is not equal to 0, right? So all I need to do is expand along this middle row here and find the value of k that would make it equal to 0, and then basically k would be any other value, okay? So let's have a go at doing that. So if we expand along this row, well, if I expand along this row, well, we start here, and I'd have to delete this row as well. So we delete this column, and then this row. So all I get left with is minus 1, 1, 2, minus 1. Okay, so and my cofactor will be 3, but remember it goes positive, minus, positive, minus. So my first one's going to be minus. So what I'm going to actually have here is minus 3. Oops, let's change it to pen. So it's going to be minus 3. So minus 3. Lots of the determinants, like we said, minus 1, 1, 2, minus 1. So we're splitting it up now into a few separate 2x2 matrices here. We can work out those individual determinants. Now we're going back up here, deleting this row and this column, and my cofactor will be k, and this time it will be positive. So I'm going to get plus k lots. My determinant now is going to be 2, 1, 3, and then minus 1. We're going to have to work out the determinant of that. And then finally, going back up here, we want this row again, and then this column. We're deleting those two, so I'm going to get 2, minus 1, 3, and 2. They're the only 4 values that are left. So it's going to be minus 4 this time again. Minus 4, it's going to be 2, minus 1, 3, and 2, like we said. Okay, so now I just need to work out these individual cofactors and set this equal to 0. So let's work this out now. So it's minus 3 lots of, so minus 3 lots of, minus 1 times minus 1, so that's 1 minus 1 times 2. So that's going to be 1 minus 2, so that's going to be minus 1 in there. I've then got plus k lots of this, so plus k lots. 2 times minus 1, so that's going to be minus 2, minus this 3 here. So I'm going to get minus 5 times k, so that's going to be k lots of minus 5. So we'll just simplify in a second. And then I'm going to have minus 4 again. 2 times 2 is 4, minus 3 times minus 1, so it's going to be 7 in total. Okay, so I'm going to get minus 4 lots of 7. And this is going to be equal to 0. Now we're just going to solve for k. So minus 3 times minus 1, I get 3. K times minus 5, I get minus 5 lots of k. Minus 4 times 7, I get minus 28. It's equal to 0. Now I'm going to simplify this. So I'm going to get 5k is going to be equal to, this is equal to minus 25. So therefore k, now remember we don't want this value, so therefore k cannot be equal to minus 5, cannot be equal to minus 5. That's the only value that we can't have. So any other value will give us an inverse. Okay, so that's part A done. So we'll just quickly clear all this. Let's jump on to part B now. So part B, what have we got to do? Well, we've got to find, in terms of P, the coordinates of the point where the following planes intersect. Okay, so we're looking at these set of vectors here, these set of equations. Notice this is identical to this. So it's 2 minus 1, 1, 2x minus y plus z. Okay, so that's my first line of my matrix. I've got 3 minus 6, 4, 3, minus, well, that was k there, but we'll call it minus 6, 4, and then 3, 2 minus 1, 3, 2 minus 1. Okay, so this is going to help us now, this m here. And then for this question, make sure you're using your graphical calculator. It will come in very handy. You don't need it, but it just saves you a lot of time. So what we're saying here is we're going to find a set of coordinates. So if I call it x, y, z, x, y, z, like so. Well, that's going to be equal now to the inverse of m inverse, times by this vector here, p10. So doing that will actually just give me the answer that I need. So M inverse times P 1, 0. And I'll get my answer. So M inverse now. Well, what I'm going to work this out is just using my calculator, but where K is, make sure you replace it with -6, okay? So you're going to put this on your calculator and then work out the inverse of it. So you do the matrix times to the power of the inverse. So if I put that on my calculator, what you'd actually get here is M inverse. I'm going to factor the 1/5 out, but on your calculator it will give it as, like, for example, -2/5, but I've factored it out as 1/5. So 1/5, 3×3 matrix. So it's going to be -2, 1, 2, 15, -5, -5, and then finally 24, -7, -9. Okay, so that's my M inverse. Now what I actually need to do is times it by P, 1 and 0, okay? So obviously you can't do this on your calculator because this has a constant in it. Well, it's got this variable, sorry, it's got this P, so we can't put it in on the calculator. So I'm going to now times M inverse by P, 1, 0. So that's going to be 1/5 on the outside again. -2, 1, 2. -5, 24. -7. So I'm just writing it all out again. Now I'm going to times this by P, 1, 0. Okay. So expanding along the top, well, if I multiply this through, it's just going to be -2 times P, it's -2P, 1 times 1 will be 1, and 2 times 0 will be 0. So that's going to be, my first value will be, so I'm going to keep the 1/5 on the outside just yet, so it's going to be 1/5 of -2P like we said, plus 1. Doing the next one now, so 15 times P, I'm going to have 15P minus 5. So 15P minus 5, but hopefully this is really straightforward multiplication. 15P minus 5, and then finally 24 times P, I'm going to get 24P minus 7. So now it's all we have to do now is times times it by 1/5. I'll divide it by 5. So what I'm going to do is I'm just going to write them underneath. We should have enough room, I hope. So what this is going to give, it's going to be minus 2P plus 1 divided by 5. And remember, write this as coordinates now. So minus 2P plus 1 over 5. I'm going to have 3P minus 1. Oops, let me just undo that. 3P minus 1, and then finally we're going to have 24P minus 7, 24P minus 7, all over 5. And there we have it. So that's the coordinates there of the point where the following planes intersect. Part C, let's have a look at what we've got to do here. So for part C, we have to find the value of k for which the set of simultaneous equations can be solved. So this is actually quite straightforward. A couple of ways you can do it, but the easiest way that jumps out at me is looking at how these equations are formed. All we can do is just substitute a point in, right? So if I say, so for part C, if I say let x equal 2, so let x equal 2. So let x equal 2. So what I'm going to get then is subbing it into my equation 1, the top one, and then equation 3 here. We're going to sub x is 2 into both of these. So that's going to give me 2 times 2, so that's 4. I'm going to subtract it off this side. So 1 minus 4 is minus 3. So I'm going to get minus y plus z is equal to minus 3. Okay, so that's the first equation. Subbing it into here now. 3 times 2, so that's going to give me 6. And I'm going to do 0 minus 6. So I'm going to get 2y minus z is equal to minus 6. Okay, solving these now simultaneously. Really straightforward. I'm going to get that z is equal to minus 12. Z is equal to minus 12. And now just to work out y. Sorry, what you would get first is that you get y is equal to minus 9. I've accidentally wrote down my second solution first. So you get y is minus 9. And then using y is equal to minus 9, you can work out z is equal to minus 12. So we've got our two solutions. All we've got to do now is sub it back into our middle one. And we're going to get the value of q. So if I do that over here, 3 lots of 2, because x is 2, minus 5 lots of minus 9. Just subbing in my y and my z now. So my y is minus 9, and then plus 4 lots of minus 12. What's this equal to? Well, that's going to be 6. That's going to be plus 45. and that's going to be minus 48. Simplifying all that, what we get is that q is equal to 3. Okay, and this will work no matter what value you pick for x. You can do z, you can do y. As long as you do everything else correctly in between, you'll get that q is equal to 3. Okay, so there you go. That's the value for q, which can be solved. And then finally, the very last part, just a 1 marker. It says, for this value of q, interpret the solution of the set of simultaneous equations geometrically. So it's just asking what happens now with this value. Well, what this is saying is that the planes all meet in a line. So the planes meet in a line. Or you can say intersect, so meet, intersect in a line. And there we have it, guys. That's the very last mark. You can also say this is a sheaf. I can't remember how you spell it. Like so. That also gets you your mark as well. They form a sheaf. But there we have it. That's question 7, fully complete.